Today I'll be presenting on my research experience from the past semester. With Susan Rowe and Dr. Bruno Rossaghini as my mentors, I was able to work on this study titled Effect of Repeated Whole Body Heat Therapy on Muscle Strength in a Mouse Model of Duchenne Muscular Dystrophy. First, I'd like to give some background on Duchenne muscular dystrophy. It's an X-linked degenerative disease, so it mainly affects boys, and it's caused by a lack of the muscle protein dystrophin, which in healthy muscle would function to strengthen and protect muscle fibers. A few symptoms of the disease are reduced muscle strength, reduced muscle fatigue resistance, abnormal blood flow to the muscle, and inflammation. All of these together can cause shortened lifespan and early loss of walking ability. In the top photo, you can see a young boy who's affected by Duchenne, and he is wheelchair bound due to a loss of walking ability at a young age. On the bottom left, you can see a sample of healthy muscle. Each of these fibers have quite a large diameter, and there's not a lot of space in between each fiber. On the right, you'll see a sample of Duchenne muscle. Each of the fibers are much smaller, and there's much more space between the fibers. Currently, the only treatment option for Duchenne is glucocorticoids. With prolonged steroid use, you'll see severe side effects such as weight gain, behavior changes, growth delays, osteoporosis, and cataracts. A recent study was able to find that repeated treatment with heat therapy improved body composition and muscle function in a mouse model of diet-induced obesity and hind limb ischemia. In this study, mice had induced muscle damage similar to what you would see in Duchenne. In these figures below, open circles represent the control treatment where mice were not receiving any heat therapies, and closed circles represent heat treatment where mice were receiving heat therapies for 3 weeks. The first figure on the left side has body mass on the y-axis and time on the x-axis. Throughout the 3 weeks of the study, you can see that control treatment mice gained more body mass than heat treatment mice. The second figure shows lean body mass on the y-axis and time on the x-axis. Throughout the 3 weeks of the study, both control and heat therapy mice sustained about the same amount of lean mass. In the final figure on the right side, fat mass is on the y-axis and time is on the x again. In this figure, you can see that control treatment mice gained much more fat mass than heat treatment mice did. So the purpose of our study is to apply these findings to a model of Duchenne and to determine the effects of repeated exposure to heat treatment on body composition and the structure and function of the soleus and extensor digitorum longus, or EDL muscles, in a mouse model of Duchenne muscular dystrophy. Our hypothesis in this study was that in a mouse model of Duchenne muscular dystrophy, animals exposed to heat treatment would display improvements in body composition, muscle mass, and muscle function when compared to the control group. This study used 24 D2-MDX mice, which is a mouse model of Duchenne muscular dystrophy, and these mice were split into 2 groups, 12 control treatment mice and 12 heat treatment mice. The heat treatment mice received 30 minutes of treatment per day, 5 days a week, for a duration of 3 weeks. On the bottom left side, you can see a picture of the heat chamber that we used. These mice were placed in the heat chamber, which was set to 39 degrees Celsius. The control treatment mice received the same amount and duration of treatment, and they were placed in an unheated chamber. Body composition was measured using an echo MRI, which is pictured on the bottom right side, and this allowed us to measure their lean body mass and their fat body mass. Total body mass was also measured in the mice. At the end of 3 weeks, the mice were sacrificed, and the mass and strength of the isolated soleus and EDL muscles was measured using this isolated muscle testing apparatus, which is pictured in the middle. First, we'll take a look at our body composition results. The groups were compared using a statistical t-test, and in these figures, control treatment is represented by open circles and open bars, and heat treatment is represented by closed circles and closed bars. In the top row, on the left side, we have body mass on the y-axis of the figure and time on the x-axis. On the right side graph, we have change in body mass on the y, and both control and heat treatment are represented. Looking at these 2 figures, we can see similar increases in body mass between the 2 groups. In the second row of figures, we have lean mass on the y-axis of the left-hand figure and time on the x. In the right figure, we have change in lean mass and both control and heat treatment represented. Looking at these two figures, you can see similar increases in lean mass between those two groups. Finally, at the bottom, we see fat mass. So on the left-hand side, you have fat mass on the y-axis over time. And on the right side, you have a change in fat mass with both groups represented. And again, there are similar increases in fat mass between the two groups. This differs from what we would have expected to see in our outcomes. Based on previous studies, we would have expected that there would be greater increases in lean mass with the heat treatment than with the control treatment. Next, we'll take a look at our isolated EDL muscle measurements. The EDL muscle was chosen because it's composed of fast twitch fibers. In our first figure on the left side, you have EDL absolute mass on the y-axis. You can see that between the control and heat treatment groups, there's not a large difference in absolute mass following 3 weeks of treatment. In our second figure, we have EDL relative mass on the y-axis. And this figure shows that following 3 weeks of heat treatment, the heat treatment group of mice did have an increased relative mass when compared to the control group. Finally, at the bottom, we have EDL absolute force on the y-axis, and between the control and heat treatment groups, there's not a large difference in that measurement. This slide shows the results from isolated soleus muscle measurements. The soleus muscle was chosen because it's comprised mostly of slow twitch muscle fibers. The first figure on the left side shows soleus absolute mass on the y-axis, and between control and heat groups, there's no large difference. The same can be said for soleus relative mass and soleus absolute force. So with both EDL and soleus muscles, we would have expected to see increases in absolute mass, relative mass, and absolute force when comparing the heat treatment group to the control group. So to wrap up those results, in a mouse model of Duchenne muscular dystrophy, the animals exposed to heat treatment did not display significant improvements in body composition, muscle mass, or muscle function when compared to the control group. And these are not the results that we expected. However, we did only attempt 1 temperature and 1 duration of treatment. So it's possible that changing the temperature and duration could produce different results. And this study leaves us with a lot of questions for future research and the opportunity to define why these Duchenne animals did not respond to the heat treatments in the way that we expected.